Okay, let's look at our last power tool. This power tool is called the lambda. A lambda is basically a function. We're going to look at a lambda in a moment. But first, I want to remind you of something that we may not actually have touched on in class, possibly in the videos. This is the use of a function for sorting. Now, kind of made up problem that we had was basically the problem of sorting a list of mixed case. When you're sorting a list of strings and you want to sort them alphabetically, you would normally think to just place that list of strings in the call to sorted, and it should sort them alphabetically. But the truth is, the default sort for strings is not alphabetic. It's actually something that we call Ascii-betic. Now, Ascii-betic is kind of a little bit of well, it's a term that relates to the Ascii table. And I seem to remember having shown you this in one of the earlier videos. The Ascii table is a table of characters, and associated with each character is a decimal number. So you can see it starts at 0, ends at 127. There are 128 characters in the Ascii table. You can see that the capital A is at ASCII 10. And if you keep going down A through Z, oh, well, that's different, isn't it? Sorry, I take that back. I was looking at the wrong thing. The ASCII A is actually at integer 65. There it is. There's the A. There's the integer 65. You can go all the way down through to Z at 90. But then if you keep going, you'll see that there's a lowercase a at position 97. This is the means by which and the data by which Python is sorting strings by default. It's not alphabetic. It's something called Ascii-betic. So as you can see, that's exactly what's happening here. You can see that the letters that I've sorted are in alphabetical order as long as you stay within the same case. ACE is in alphabetical order. BDF is in alphabetical order. Of course, the capital letters come in front of the lowercase letters because of this ASCII character set and the associated integers. Uppercase A is 65, lowercase a is 97, and that's the reason we're seeing uppercase letters first. So the big question is, how could we sort this list of strings so that they're case insensitive? It may not come up a lot, but it does allow us to discuss the application of a function to each item in order to effect a solution. The solution here is to simply apply the same function to every item in the sortable list. We're not actually changing the item, but what we're doing is we're giving Python a criteria by which to sort these items. That is, don't sort B or A by its uppercase value, sort it by its lowercase value. Do the same with C and E. B, D, and F will have no effect if we lowercase it. So what we're getting as a result is a nicely sorted alphabetic sort on strings by simply applying this little patch that says don't sort by the string's actual value, sort by its lowercase value. And this is what the function does. Now, this isn't so much a review of sort functions as it is to discuss how a lambda works. What I'm going to show you is how to replace the sort function with a lambda. A lambda is actually a replacement for a sort function. We can actually call a lambda a single statement function. It's a function that works within a single statement and allows us to place that lambda, that function, inside a place where a statement could go. And the place where we're going to put it is right here. We're going to replace what we did in by lower with a lambda. I'm going to make a quick change to show that I'm working on new data. and then I'll see that it still works the same way. Now, what I'd like you to do is pause this video and look at lines 8 compared to line 3 and 4. See how the lambda in line 8 basically covers what we're seeing in line 3 and 4. And this may remind you of a list comprehension. Lambda is basically doing what a list comprehension did. It's taking multiple statements and re-expressing them as a single statement. Go ahead and pause the video and just take a close look at how the lambda is basically saying what bylower is saying, but it's saying it more efficiently. Actually, I should take that back. It's not that the lambda is saying it more efficiently. It's saying it more economically, meaning it's saying it in a shorter space. And most significantly, it's a single statement. A lambda is a single statement, whereas bylower, the function there, is what we call a compound statement, a statement made of multiple statements. So what did you notice when you compared bylower to the lambda? Well, we have an argument and we have a return value, and that's true of bylower. The argument is arg on line 3, and the return value is arg.lower. That's the value being returned from the function. Well, this lambda is the very same thing. It's saying, let's have an argument arg, and let's have a return value arg.lower. It doesn't have a return statement, basically because the code to the right of the colon is the return value. This means that lambdas are somewhat limited. They can take multiple arguments, and that's what'll go on the left side of the lambda. On the right side, we need to have a single statement that can serve as the return value. And again, if you go back to your list comprehension, you'll notice that when we did the transforming list comprehension, we needed to have a statement on the left. So I had a list comprehension that said something like this: x dot split second item for x in list, my list. Or, if we wanted to lowercase each item, x dot lower for x in my list. In other words, the statement on the left of the 4 needs to be a single statement, and that will be the value that is passed back to the target list. Now, when we talk about a list comprehension, we're not talking about a function. We're not talking about a return value, but we are talking about a single statement that serves as basically the resulting value. So bylower takes an argument and returns a value, and the lambda is able to express that in a single statement in this way. What's interesting, and what you'll see as the limitation, is that because the function is so simple, they came up with a different way of saying it, a way of saying it that really makes it very straightforward. What this means, of course, is that lambdas are limited to very simple functions. You can't have multiple statements in a lambda. You can't, for example, say, arg plus a and then arg.lower. That's not what a lambda is used for. If you wanted to have multiple statements in your function, you would just use a named function. So why do they even have lambdas? Why do we even have them here? The answer is because there are times when we want to work with a very simple function and we only want to use it in one isolated place. Now, normally when we define a function, we like to put the function near the top of the script. That is, we like to put all the functions together in the top of the script to ensure that when we actually call the function, we've already defined it. And that's probably the best way of describing why we have functions at the top of our program. We want to have them defined before we call them. In the case of a lambda, however, in the case of a sort function, if the sort function is so brief, if it's so short, if it's so simple, that it seems like extra head space work, extra thought work, and extra really editing work to get the function to be a separate function that's loaded along with all the other functions, then it might make more sense to come up with a statement that serves the same purpose and can go exactly where it was being used. Keep in mind, we're replacing bylower. The statement that we had before was to say key equals and then give the name of the function. So compare the statement on line 8 and the statement on line 10. They're basically doing the same thing. The only difference is the bylower function is being defined elsewhere and referenced on line 8. And on line 10, the lambda and the reference to the lambda are in one and the same place. We don't even need to put a name in the key equals because we're defining the function right there. In that way, functions and lambdas are very, very similar. They can take one or more arguments, they can return one value, or they can return a tuple of values in the same way that our functions have been able to do. But they can be expressed in one statement, and this just allows us to keep things nice and neat, straight to the point. We don't need to maintain a separate function elsewhere. We don't need to ask the reader of our code to look for the separate function elsewhere. We just have a nice, convenient place where the lambda is defined and where it is used, the same place. Okay, let's look at one additional example. That can show us some of the fancy footwork we can use to turn a simple function of multiple statements into a very simple function of a lambda. Actually previewed this when we looked at list comprehensions. You can, as we've described, a lambda needs to be a single statement. Lambda can take multiple arguments, and we're not going to see any examples of that because we're really just using lambdas for sorting, although it can be used for other things. What we want to emphasize is that the lambda is required to return only one statement. Otherwise, there's no real point in using a lambda. Here's what we can't do. We can't say, let's have multiple statements. I mentioned this before. If I wanted to try to do in a lambda what I'm doing in the function above, and we should probably review that as well, I might have to think about using multiple statements. Actually, let's just step back one moment and look at by last name. Now, we looked at this when we were looking at sorting. You can see that the sorting list that we're using is a group of names. When we work with a group of names like this and we want to sort by some other value than the actual value, we're going to have to use a sorting function. In this case, we have a list of names, and each name has a first and last name in it. Like I said, we've gone over this before, but it bears reviewing. If you look closely at the by last name function, you can see that it's taking a string. The string is a name with two parts. We are splitting the name into pieces and then returning the second item in the pieces. We're returning the second item of the split. Now, of course, before we move forward, it would probably be necessary for you to make sure that you understand what's going on here. When we run this program, we should see that the names have been sorted by the last name rather than the first name. And that's because the sorting function is sort of like a criteria function or a helper function. It's a function that says, okay, you want to sort David Blay? Well, then sort David Blay by Blay. So if full name comes in as David Blay, we're returning Blay. And we're thus telling Python, or telling the sorted function, that if it wants to sort David Blay, the value by which it should be sorted is Blay. That's how sorting works. That's how sort functions work. Okay, fair enough. Now, we want to replace this with a lambda. And again, I wouldn't go further until you understand how that function is working. But as I mentioned, if we were to attempt to code this as a lambda, and why don't I just change this, these names to shorter names so that I can make perfect sense of them in the lambda, or that I can use the same names. here we're saying lambda fn dot split, and then what? Oh, did we say items? it equals fn dot split, and then let's say it negative 1. This would be us attempting to convert that function to a lambda, but it's not going to work. It's not going to work because we have two statements in our return value, and that's not what a lambda is for. A lambda is designed to work as a function that's usually very simple, that can be translated into a single statement return value. If you have multiple statements, you should just use a function, and that'll work fine. This is why we're calling this a power tool. You can do it without a lambda, but we're just going to show the ease of use by which we can use a lambda. The question is whether or not we could actually make this function into a lambda, this function that appears to have two statements that are necessary to prepare the return value. The question then would be, could you combine lines 4 and 5 into a single statement? Is that possible? Well, if you consider that split returns a list, and you consider that you can subscript a list, it is indeed possible. We can simply take the split and subscript it directly. Now you'll want to maybe pause and stare at this one as well. We're not going to need the assignment. We are only going to need the return value. And the return value is the argument, split, and then the last item returned. That's it. This lambda has been successfully used now to replace the by last name function, and we can therefore place it right where the key equals argument is to say sort by, and then use this function to transform the item to be sorted so that we can see the value by which it should be sorted. And we should see that it works in the same way.